Is it visible?
No, still not yet.
It's not.
It's not. It's not.
Just give me a moment.
Visible, Gaurav, you can see Nishan's face, but not his screen, I think. Thanks for that.
Sir, I guess it is visible. Like Tanya is saying it is visible.
For me, it's not visible. Uh,
Maybe you just need to stop your screen at your end. Okay, let's start. So, in our last session on July 26th, right? So we had the pleasure of introducing you to Capricorn, which has now been rebranded as Arkansas Private Limited. We discussed how to effectively utilize Inventor to transform your 2D design into captive 3D models. As you all know, I am Nishant Bhardwaj. My designation is Customer Success Advisor here, and these are my contact details. I'm responsible for all the queries and challenges you might have in future. You can call me directly. You can mail me. So I will be responsible to solve your challenges and queries at one place. Uh, Arcans is committed to providing an exceptional customer service. Today, we will highlight three key aspects of our offering. Right. Number one is expand your network at Arcans events, dedicated technical troubleshooting, and comprehensive learning management system. So at Arcans, we believe in the power of networking and knowledge sharing. Our events provide a platform for you to expand your professional connection and stay updated on the latest industry trends. Whether you're looking to collaborate with industry peers, to learn from our experts, our events offer valuable networking opportunities. When you partner with Arcans, you can count on our dedicated team of technical experts to provide you personalized support and resolve any challenges you might face in future. Our experts are committed to ensuring your seamless experience proactively and helping you overcome any technical issues. Let me introduce to our learning management system. So, elevate your skill with our comprehensive learning management system, offering a wide range of educational resources and training opportunities. From self-paced online courses to interact workshops, our LMS enables you to develop and refine your expertise at your own pace. So we are having a recorded sessions, recorded videos for all of you with your relevant topics. You can access that from our a learning management system, and we'll provide you the access. You need to just ask from your relative person. You can ask me directly, and after that you can learn at your own pace. Right right now we have a session 2. So today's agenda will explore how to seamlessly connect 2D and 3D and FEA simulation within the Autodesk product design and manufacturing collection. So get ready to unlock the full potential of your design and manufacturing process. And finally, we will open the floor for Q&A session where you can engage with our expert and get answer to your pressing questions. So, Mantesh, sir, over to you, please. We are Arcans, so everyone as now are like know that we are Arcans. It is changed. We are moving globally.
mhm. Thank you, Nishant. Uh, okay, kindly confirm once you can able to see my screen. Can you able to see my screen?
Yes.
Sorry, when I started sharing initially, I paused it. That's why I couldn't able to see my screen. Sorry for that. No problem. Again, myself, Mantesh, as usual. Today we are here to learn on 2D to 3D. Probably it's quick overview of our previous session was we learned how to bring CAD files to Inventor in three different methods. The first one was like copy and paste, where seriously we are losing some constraints. And we had one more option like insert from AutoCAD. Still, we can able to grab some constraints there with a geometrical option, but we couldn't able to have a link between CAD file to Inventor. And the third was something we imported the drawing. We in terms of like Autodesk, we call it as GWG underlay, and which has a link between AutoCAD to 3D model. Today, we will learn like linking of the files with an FES simulation. What happens if I change in my 2D, whether it's going to update in 3D? We saw that in the previous section. Yes, it will do. And how about like FES simulation? Is it? So even we heard few of the attendees, they called me and like told, you have some ready data sets. That's what you will be doing. Can you able to show me from the scratch? Today I thought like, okay, let me start everything from the scratch. So we have hardly about like another 48 minutes. So I'm going to take another 40 minutes of your guys, and it will be one of the fantastic session. Nothing to do with the PPT. I'm not covering much on PPT because I know that I'm addressing all technical person. So let me start from AutoCAD. Okay, this is my AutoCAD. Just I've launched the software. I'm going with like new file with metric units. Okay, I'm going to create few of the conceptual design. See, nothing I've created prior. I'm going to show you everything lively. Okay, including from drafting of your CAD softwares. I'm going to show you. Simple thing. I don't have even layers in this. See, you can see. So I don't have even a layers in this. So if we are learning something, let us learn from the scratch and let us learn this 100%. Okay. I'm going to create some support type of a structure. Okay. Okay. So let me say it as some 400 units. I'm going to copy the same thing for another 200 units. Let's say 150. It's enough. Okay. Circle. And again, one more option. Say dice 70. Similarly, I'm going to create line for another 100 units. 25-degree. Similarly, I'm going to mirror it. So this is one of the product support, whatever you can observe. Whatever you can observe. Guys, National Buzz webinar. Okay, I'm going to create few of the things here. Okay. Let me crudely create an example here. Okay, I'm going to trim this. Okay. Now, what happened? So this is my actually the base part. So nothing is there in 3D. So I'm just giving a confirmation. We are working completely on the 2D thing. But then again, I have some curved area here. Now, so this is like a front view. If I take the side view of this, okay, let me create a side view of the component. Maybe I may have few thickness, is it? Let us take it as thick of 20 units. Okay, frame. And in between, I have some space for about 150 units. And toply, this is getting interconnected. Okay. So how it's going to interconnect? Probably through a product. Okay. And even you can consider it as some cylindrical type of object. It is getting connected. Maybe about 60 units in dia. Okay. And I am going to make this as some center line. Now we don't have layers. I'm going to create few of the layers here. Then set as center line. Load. Okay. Some center. Okay. And I'm going to select this. I'm going to create only one layer for this. So I'm going to push this guy for my center line. Okay. And let the color be on yellow. Okay. Right. No problem. But this particular object is in hidden line. Okay, let me move this to one more layer. Okay, so let me create. If you are using AutoCAD Mechanical, probably you can use all this layer through like AutoCAD Mechanical setting. And let it be in the color yellow. Okay, so let me post this for my hidden layer. Okay. Now, the thing is like, I want to connect this 2D entity to 3D. Okay. I want to connect this 2D entity to 3D. How we can do that? See, earlier we used to move this to origin. Okay, let me move this to origin so that I want to make sure that how an universal coordinate system links from 2D to 3D or from 3D to 3D files, whether it's a step, IGS files, whatever the data is flowing, only the origin, if it is a neutral files. I want to save this component. So intentionally, I created already a new folder. See, nothing is there in new folder. I'm going to say it as 2D drawing for 3D modeling. Save. Okay, now I have to convert this to a 3D model. So let me go to Inventor. And as usual, no. So last time I have not created a project. Probably if you're already using of Autodesk Inventor, you'll be knowing how to create a new project. Let me create that new project. Okay, bit off. This is one more challenge if you're using about a high resolution system, like automatically your screen or the pop-up menus will get enlarged. New single user project. I'm going to say it as for FEA. And the project folder location, I'm going to browse the folder named as delete. Finish. Done. Metric, standard IPT. You can see this. I have like files like side view and the top view. Just I'm going to save this, Control S. For reference now, let me have few dimensions. Okay, so this is about 130. Control S. So I'm going to close this 2D so that using import command, directly linking through my project folder, 2D drawing, what we have created, open it, I'm going to place it on my XY plane. I'm going to make origin here. See, I'm selecting the origin here, but in the 2D file, probably the whole center was the origin. See, now you check. If I check on my center points, origin and origin both are located. So when we are importing the file, it will allow the user to select the origin. Okay. Because we work with like 2D. It's either it is an hidden line, center line, everything is visible. It is not asking while linking, like using like DWG underlay by using like import command, nowhere it will ask that can we control the layer. Now what happens? Now I want to create it as a 3D model. Is that? So I'm going again with the sketching environment. See, planes are very less in size. You can resize them. I'm selecting the plane which is parallel to my front view, and I'm going to use project DWG geometry. Even if you want to avoid this, you can convert the objects. So this is interconnection. Now I won't need this profile. Laterally I can add it, because again, even if I add this, again I can say it as visible or share the sketch and I can extrude it. Okay. So let me expand this guy also. Right click. Okay. Finish sketch. I'm going to use extrude command. This is on the other part. Let me include it on the plate. Extrude, extrude. Okay. And the thickness, is it? I can use measure. See, I'm not defining anything. I'm linking from my 2D file. Okay. Again, I want the same thing with an offset of 130 mm. See, not all CAD can be linked, but I can reduce about like 40 to 50% of my drafting hours. Is it? Now it's about like 130 mm. What is the best way of optimizing my job? So that I want to recreate everything. 130, okay, I'm going to create a stud for 130. The sketch is there. Extrude. It's nowhere asking for the sketch. Start 2D sketch, select it, and I'm going to say like project geometry, same sketch, finish. So 130 is the unit. Either I can type it or else I can take the reference. Okay, earlier we took a reference. Then I'm going with the plane option, mid between two faces. Then I'm using the mirror command. So in the pattern, no, you can able to find the mirror. Feature is this. Mirror plane is the center one. Done. My components are ready now. Now changes done in the 2D profile is going to affect in my 3D. Is it? Now let me hide this work plane. Visibility uncheck. To do an FEA, obviously we need the material properties, is it? Still now I have not assigned the material properties that given the intelligence. Let me take the material as steel mild. Oh, I missed it. Steel mild. Now we have assigned the material property. Let me save this part. I'm going to say it as connector part. Same. Most of the times these things are in the bigger size, it's available in the railway engine. Sometimes even it looks like small version of your vehicle chain, is it? But I've taken it in a large format. Now, changes done in AutoCAD. Let me see. Let us go to AutoCAD and do some changes now. Okay. I'm going to increase this. Right now, the measurement is something is 60. Okay. If I change this to 80, I'm going to get it here. And I'm going to use some fillet 10 radius. F enter, sorry, F enter, R 10 is the radius, already test taken, very small in size. Let us avoid the short terms so that we can able to get the very good FEA results. Okay. Okay. Now we have changed it to dia 80 or something like cut out something you need to add. You can add it, whatever you save in AutoCAD. With Inventor now, it needs an update. Accept it. Sorry, some problem. Let me close. Showing it as write protected because I launched in both the software. I don't know what was the problem. Let me recheck. Problem in the project geometry option. Project DWG geometry. That's why ensure that when you're projecting any object from AutoCAD, it has to be in polyline, or else you can use certain commands like boundary and you can pull the data. Okay. Finish. Seriously, give me a minute. Let me cross verify this. Accept. Edit feature. Okay. Now everything is okay. Save it. So my product is ready and it is communicating with like 2D. Whenever you cut some line and like close boundary, you make it as an open boundary. But how to avoid this mistake is, so this is like single entities, is it? You can use some polyline edit command, multiple, join all the thing, turn it into one. See? Now, whenever it is a like continuous line, you won't get more on the error. Whenever you have some open loop, while using fillet and other things, it will become an open loop. Then the associative will be lost because Inventor to extrude, it needs a close profile. Am I clear? Now, before getting into FEA, okay. So I have to close these gaps. I can use like direct edit. 20. Or else I can go to extrude. Again, I can maintain the associative like saying project geometry, finish to this face. Okay. Same here. Extrude. Start 2D sketch, let's say. Then project geometry. Finish. Extrude till this face. Now what next? See, why we do an FEA? To optimize our model. Is it? Now I'm not good at like recreating the shapes and other things. Is it? But I want to save my time. At that time, in Inventor, we have an option to do an optimization. But for that, you need to know all loads and conditions. That is the major thing. How to do an optimization? Before getting into an FENO, how to optimize this model? Just go to like shape generator. So this is available with your Autodesk Inventor Professional. And here also the core solver is Nastron. Now, so material property is already assigned in the 3D model. I want to have constraints in this. I'm using like fixed constraints. Where I want to fix this? Somewhere here and here, apply it. See, this area is fixed. Okay. Then I'm going to get some force somewhere on this and this, and it's a equally distributed on both the face. I'm going to take it as some 800 newtons. Apply it, cancel. Then always ensure that if you want to define gravity, define the gravity. Oh, gravity is in this bottom directions. Okay, I'm going to say like gravity, and let me define the gravity in by using some modeling area, then the Z direction about okay. Check. Edit gravity, it's in not Z, it is on X direction. But modeling. Or else I can delete that and let me recreate. Gravity anywhere. X direction. Okay. Now it is okay. So that the material or the load flow from element to element, so it will be like uniform. And we always know here, if I want to have a weld, I can enter into like inventor welds in environment and create a weld so that you will get like very actual results. Okay. But everything is already bonded. Now I have defined my material, then constraints and the load. What is next is mesh view. I'm going to say it as mesh so the elements can be divided. And I will tell the software, this is what the loads and this is my conceptual shape or the final shape, but still I want to optimize my design. Pick in like shape generating setting and okay. Generate shape, run. Now in this, if you have missed anything, like, so according to the procedure or the protocol, what simulation needs, if you're missing a bit of a thing, it will show as an error. So that you need to overcome that and fill it. Okay. It's not only on the part model, even if you have an assembly, integrate that as, pull it into like new part file and make it as like, import it as one component. Okay, then you can able to execute this. But if you have an assembly, shape generator is optimized only for shapes, not for the complete assembly. If you have complete assembly, then pull that model like individual shape, generate the shape, then assemble it, then bring it into an FEA. So this is on the part level. I'm going to highlight this works on the part level. If you want to do something on assembly, there is an alternate way. You can pull that part as an, you can pull an assembly as a part by using derive command of your part model, and you can make it as a part and you can execute it. But still after doing that, you need to execute that part by using an FEA. You need to cross verify that part. Still this is working, and even in shape generative design or sorry, shape generator, the engine behind the simulation is Nastron. So based on your RAM and the load capacity, it takes the computing results. Okay. And even it will analyze like every elements are connected to one another. If you observe in this, we don't have the contact set. Why we won't have the contact set? Because contexts are defined from one part to the another part. If it is only one part file, so as earlier I told you, like shape generator is works with only parts. At that time, I want to optimize this. That's why whenever it's on a part modeling, we don't have that context set defined in this. Showing that, see, loads are here. So this is one of the shape I can promote it. Okay. So if the load is here, so we are like over-design the product. Is it? At time, so which are the elements I want to retain is based on these loads. These are the elements. What I can do is I can retain this shape, but I can remodify my model. Okay. Let us check load criterias and redefine this. What happens? Let me give the loads from the top area. Okay, let me go to shape generator. Steady is there. Let me delete this force and the gravity. Then reassign the loads. Direction is this direction, about like 800 newtons. Apply it, cancel. Now generate the shapes. So based upon your processor speed and the RAM, the results will be. Sometimes if you are like very larger part, it may take about like 2 to 3 minutes. Processing. Okay. Probably even I will forget every time. No, we need to close this file, but I will keep open. That may cause some errors. See, it is asking for some auto update. Let it be. Let me get some results and shape generator. See, only this area, but we have created like more material outside. Right? What I can do is just I can optimize this design. See, anyway, I can reduce the sizes here because anyway we are applying the load here. Just I can come back to my 2D and I can reduce this shape instead of having some diameter and other thing. I can reduce this because my part is over design. Anytime you want to change the radius, you can change the radius. Okay. Anyway, I need that for some extra production. You can save it, come back, update it. Again, problem with extrude. Sorry, again, my mistake. Probably like we have a small fillet there. I want to delete that. No problem. Let it be. Now, the same drawing, I want to check with my FEA simulation. What I can do, just pick on like environment, inventor Nastron. Okay. Material already we have defined in the part model. So whatever you have defined in the part model, the same material is followed with your FEA simulation for Nastron, either for your shape generator. Just I can show you like picking this. What is the material we applied? Mild steel. See? So structural thing and the general purpose and idealization of the material, it will retain from the part. See, steel mild. Okay. Just you want to check the properties, you can pick on like material and you can check the property. Here, no, anything you want to change, you can change it. This is the first thing. Or if you have not applied any material, then you can pick it on the idealization, select material, then you can change or adopt a new material. Either from like Autodesk material library, if you are crossing the data from like Revit and other thing, you can use this. Or already with Inventor, you have created some custom material, you can select it from here. Okay. Now, next is idealization. Why this idealization we are using? Whether few of the components now we use like L angle, I sections, is it? Then what we do is after using these things, L angle and I section, we want to simulate whether it should work like a structure shape. Whenever it's a structure shape, the skeleton model comes into picture. Now to convert them as solids, and I want to do it. So this is one idealization is one area where you can convert from structures to a finite elements. Or else you want to do a structure simulation, you can change the steady type. How to change that? Now I'm using like linear static stress analysis. Okay. Pick on here, then edit, then linear static. See, I can use my normal modes or impact. So we can able to do about like 16 different types of an FEA with Inventor Nastro. Okay. So I can change my state. Okay. Then options. So whenever I select it as a bonded connection, it will be a weld connection. Okay. Change it. Then the same way idealization is done connectors. If you want to really use some fasteners in this, assume that few of the FES softwares, if you have inserted the content center of your library, it fades. Why means the small nut and bolts will be there. So the meshing mode passes. So at that time, we need to filter the model like without having the design content center, we need to pull it. But I need a very accurate results. Okay, at that time I can have those connectors here. Connectors in the sense means you can have like any types of nuts, bolt, fasteners. Okay, cable, spring, or a bolted connections. These types of connectors you can able to add it. It's a rod connection, cable, or a spring type, rigid body, or a bolt. Okay, rigid body means no gap, no suppression, no movement. So that is what like rigid body is. Okay, structural members. See, if it is beam, I can convert it as a solid. Even you can do that in idealization, or else some structural members you can convert directly to solids. Next comes with like constraints. Okay, I want to use fixed constraints. Okay, in all the direction. Okay, let me apply on this curved surface and sizes density. So this is the constraints I'm going to have. Next is load in minus x-axis. This is x minus 800 newtons. So where I want to apply on this face, then we use the sizes like more and density bit of less. Okay, I want to redefine the load. Edit. Sorry, it's on minus y. Yeah. Now what next? Context, single part. Probably I can use like automatic context. Anyway, in the steady type, I have defined it as a bonded connection. So generate mesh. Good. Then run simulation. Probably my product is over designed. Now let us check. Deflection is 0.3, not even it's visible to an eyesight. But as a software, no, it indicates more. Okay. Now let us check animates. Like 0.3 is not visible to an human eye. when you apply like that much of load, but it shows like the deflection. And I am going to highlight like whenever it's a red color, it doesn't means you have like more. See, you can observe the red color is the area where you have the maximum deformation. Okay. 0.3 for about like 1 meter is nothing. But see, if we say like converging for 1:1 scale, the results now we cannot feel how it is passing. In the software, it shows that. Now stop the animation and we can check on like displacement here. The results is there. Okay. Maximum is somewhere in the peak. Okay. And I want to check with my one measure stresses. So 0.374 is one measure stresses, that too in the center, exactly where we, even if the stress level of the red highlighted area is not crossing 50% of the thickness, then only on the peak it is having, we can ignore the stress by considering it as a peak stress. Peak stresses, we get it somewhere in the sharp area or very cylindrical face, on the top face of the cylinder, like this, you will get it. But the stress value is very less. So it means that I can able to go ahead with still more optimization. But as per like shape generator advised, so if you are applying some loads, I can able to have like very straight line. So this was the generative design shape it has given. See? That I can still optimize my model. And even I won't need anything on the top area. I can cut down. At that time, again, I can come back to my design. So, and how to check the safety factor is, you can pick on this safety factor. Still about like some 196 is a safety factor we have. So I can apply about like another 400 times, oh sorry, 150 to 160 times more loads. 150, 160 into 800 I can apply to withstand my loads. This is how like, see, safety factor is on this particular design. Don't get confused safety factor versus factor of safety. I've seen many engineers, they'll get confused. Safety factor is the result thrown out from your NFEL. Factor of safety, like while applying the loads, by taking the standards, we are applying like factor of safety. Okay. Safety factor, still how much load it can withstand. Okay. Like whenever we are taking something on board with aviation technology, we consider the safety factor as 1.2 because everything is on the fly. Now we are taking on like off board, we consider for safety factor as 3 units. Somebody, if you have designed for 100 kg, you need to apply the load for 100 kg, then the product has to be designed for like 300 kg if it is off board. Whenever it's on board, it must be 1.2. Okay. So these are the things you will get it in the standards which you follow. Okay. So let me say like finish this and I can come back to my modeling environment. At any time you want to change the shape here, I can change the shape. Like can I have some material can be removed here and finish, extrude, cut through all. Still, why morning it was not giving problem. Some problem in this. Okay. Let us update this and go back to extrusion one. I don't know why it's even not there in 2D. It's giving some error. Just you can try with this. Changes done from AutoCAD, it will reflect here. I don't know why my thing is giving a problem. Yeah, probably of these guys. Let me join this as well as this guy. No, I think this will be okay. This is one thing I usually forget, like save the drawing, update it, accept. See, fillets will always cause problem. That's why we always do like post-processing. Okay. Small fillets, sharp corners, just remove them. And I can use some default planes. Visible, mirror, the slot, mirror plane is this. Okay. Still, again, you can subject this model for an FEA and observe the results. Then again, still further, you can optimize the model. So now if you have any questions, you can ask, or you can type it in Q&A. If you need for, yeah, I have something in Q&A.
I think, sir, you elaborated so well. Nobody has doubt right now.
No, it's not doubts. Probably some few of them doesn't know what is FEA, the difference between FE and CFD. Now we had some bit issues with AutoCAD. Like I would have closed that file, but I've not closed it. Don't forget when you want to connect from 2D to 3D, whenever you change in 2D, close that file. Don't keep it in open because .dll file is one thing which will communicate with your inventor file. Whenever you keep AutoCAD file open, DLL file will be working. Okay. Ensure that you are closing your AutoCAD file. Any doubts, guys? Next session is on probably like when is the date? Uh,
Sir, next session will be on 23rd of August.
23rd August. We are going to see 2D layout creation, then how we are bringing it to a 3D layout, and then how we are taking through a walkthrough. Okay. Mahesh is what exactly is FEA and CFD? Can you explain the difference, sir? See, FEA is finite element analysis, which is mainly done on solid parts. Okay. CFD, okay. CFD is something like I have a pipe, inside a pipe, there is a water flow. Now I have to check like if I have a diameter 4-inch pipe, okay. If I have velocity of like some pressure or velocity at one end, so the pipe is about like 600 feet length. What will be the pressure at the output? So this is called a CFD. Okay, now that is one thing, and even it will connect with the airflow. I have HVAC system. Okay. Now air handling unit is somewhere. Okay. And HVAC ducts is 400 by 400 here. At the end, it is about like 200 by 200. At the end, I'm going to get that air pressure or not. So like that, now before erection or before manufacturing, you can able to check the flow, what is the input output. And if you have any branches, okay, now there is a 90-degree turn. Okay, now 90-degree turn, how is like air coming and hitting and going. Now for that velocity, my material will get erode or not. These are done in with the CFD. Okay. And even in CFD, like you have like 100 different domains. Okay. Even in FEI, you have like more than like 40 plus simulations. But in that, we have seen only one. Any other questions, guys? Okay. How was the session? At least just type your feedback. And one more thing, when you are doing an FEA, always ensure that there is a pre-requirement, like pre-processing. Small fillet, small holes, you remove. Now, what is the load I want to put it? There are two components now. On the two component, what is that load? One is like self weight. We define it through a gravity, and there is some external weight like 800 newtons and the gravity. There is another part connecting to the bottom. You doesn't need like the entire thing you want to simulate. Collection of loads, you take it where it is getting contacted with the bottom plate or bottom object. No, you put that collection of load to that one. If you don't have that hardware capability and other things. Okay. And I'm going to tell none of the software will tell your product is going to withstand or not. It gives the results and it's your intelligence or it's your knowledge how you're reading that results. So never think red means design is failed. Red means that is the area where actually the stresses are more. Red doesn't indicate your product is failed. Okay. Anything else, guys? If you have any queries, kindly post it.
Gaurav Patil says thank you. It was a nice session.
Yeah.
Session was very
Madhu,
informative.
okay. Tiwari, can we check the design reliability using FE? Yes, definitely you can check the design feasibility. Okay, but you should be good at engineering physics. Okay, and the material properties. Vinayak Manjrekar, this session was good, sir. I would like to know from you that how Nastron different from ANSYS. See, ANSYS is the software from one OEM, and Nastron is one of the tool. No, it was developed by NASA. We all know like NASA, like ISRO in India, NASA in US. Okay, so this Nastron tool was developed by NASA. ANSYS and Nastron both are competitors. Okay, but ANSYS they have like n number of domains, but in Nastron, no, they mainly focus on only FEA. For CFD, we have another package. Okay. So that package is entirely different. ANSYS has one OEM. Under them, no, they have like all the domain. If you want to check the blood flow in the nerve, even ANSYS will do that. Okay. But in that ANSYS, no, you have like n number of domains. In that FEA, you take it. We compete ANSYS FEA with Nastron FEA. And before releasing this particular product into the market, no, we have done about like 50,000 physical prototype and validate the result with the what it is given from the software. Okay. We call it like physical prototype versus digital prototype. Maruti, okay. Informative for new part NPD, new product development. Okay. Manjrekar, thank you. Thank you, Manjrekar. Moses, hi, sir. Can we use standard codes for design and ANSYS analyze. See, standard codes, it comes mainly on civil aspects. Okay. Like this geographical location, this is what the standard codes. Most of the time, standard codes are available in StatPro. Okay. So in StatPro also, what we use it based on like geographical location, we assign the codes. Okay. But FEA is one thing, no, we always work on gravity. Gravity is the only code. And factor of safety we will consider because this is the design done for the products. Now, you take like somewhere in Germany, the gravity is less compared to like South India. Okay. And what the code, we won't follow any code, we follow standards. Now let us take like ASME standard. So in terms of like mechanical, so if something is like off-board, no factor of safety, they always consider like 2, where whenever it's a consumer product. Now there is something we are working on defense product. They'll consider the factor of safety as 3. Like 100 kg, it has to be withstand means we need to deliver the product according to ANSI standard. It should withstand more than 300 kgs. Okay. So codes and standards are entirely different. So we follow standards for product design. Okay. Like robotic structure analysis we have, which is equivalent to your StatPro. At that time, no, we follow codes because every course is inbuilt in the software. There I can able to apply the codes. For steels, yes, you can apply the codes for steel structures. That's not a problem. Obviously, what are the steel structure shapes you are selecting in inventor, no, automatically it will take those codes.
Mr. Braja Gopal has raised his hand for the long time,
Yeah,
so
yeah,
he is allowed to talk if there is any
yeah,
issue.
yeah,
Like,
please.
yeah.
Goswami, you can speak, Goswami. Guys, if you want some information, but you couldn't able to type those things, means we can allow you to speak.
Just
Okay,
raise your hand.
just
Yes.
raise your hand. And even no, assume that you really, this is very good for FES simulation. You want to learn this FES simulation. If you need some tailor-made training that to on your product, we can deliver that. But this will be like, we take it like a service job. It's not a complimentary if you have procured the software because this is something premium requirement for every customers. Gopal Goswami, I think still you have facing challenges with the mic. I'm going to open this Q&A for another 2 minutes. It's already 4:05. Session will be open for another 2 minutes. If you have any queries, please type it. And if you're all using Inventor Professional, no, you have one good news that if you copy any files and paste it in the same folder, no, you change one file, the second one was getting updated because everything was linked through a project file. Now that has been overcome. You can copy and reuse the same file for as a different design. Okay. Till 2022, that option was not there, but now Autodesk, they have released that option in the latest patch. Like same file, you copy and paste anywhere in your drive, change one file, both were getting updated. That has been solved. That is one of the enhancement which is there. If you are using like 2024 or 25, any version, you update the patches. So that option is enabled. Okay. And one more thing, in FEA of Nastron, you cannot add seismic loads. Remember that if you are assuming like, okay, I'm working on steel structures, can I able to add seismic loads based upon these codes or these geographical location? No, this is not for your seismic load. Okay, even you cannot put wind load. This is completely on the product design. But alternate way of validating the wind, no, the pressure of the wind can be calculated and applied as uniformly distributed load. That is the alternate way of working. But in something StatPro and robotic structure analysis, you can apply both wind load as well as your seismic load. This is not meant for that particular thing. Okay, this is purely on product design, like IC engines, brake arms, automobile thing, or heat transfer of any products. It may be something like solar panels. Also, you can check what is the heat transfer. Okay, then what is the temperature loss? You can validate. This is mainly on like product designs. If you have something as a product, you can use Nastron. Okay. I think Nishan, there are no more questions. Gopal
Thank,
Goswami, just if you still, we are sorry that we couldn't able to allow you to talk because some challenges with the hardware. Still, if you have doubts now, kindly give a call to the person who has sent an invitation to you. Either Nishant or me has sent, probably would have sent the invitation. So if you are calling Nishant, he will look to me. We can have the small discussion over the phone.
Thank you everyone for attending today's webinar. We covered a lot of great information today. I hope you found it valuable. So just a quick recap, our next webinar session will be on August 23rd. In that session, we'll be diving deeper into connecting 2D and 3D with factory layout planning. So be sure to mark your calendars and join us then. And I hope you all have a wonderful weekend. And I look forward to seeing you again soon. Enjoy the upcoming festival season. Thank you and have a great rest of your day.
Yeah, congrats to everyone for the hockey bronze medal yesterday. So let's celebrate it for the day. Thank you. So we'll meet on
Thank you.
23rd August. Yeah, thank
Yes.
you all.
Yes.